All right, before we start this page, I wanted to remind you to find the average value of a function. You're going to do 1 over b minus a times the integral from a to b of f of x dx. We add up all the values, and then we essentially multiply the change in x, which is 1 over b minus a. So remembering that, let's look at this next problem. It says the world population, p in billions of people, from 1951 through 2000 can be modeled by p equals 0.0004 t squared plus 0.053 t plus 2.43. And this works from 1 is less than or equal to t is less than or equal to 50. So here the 1 is going to stand for 1951. The 50 stands for 50 years past 1950. So it seems to me that here t would be the years past 1950. So that's what it says. It says where t is the year with t equals 1 corresponding to 1951. It says find the average population of the world from 1976 through 2000. So again, t is the number of years since 1950. So this would be t equals 1976 would be 26 years past it. And for 2000, that would be t equals 50 years past it. It wants to know the average population. So we're going to be using the average function here with our a value being 26 in this formula and our b value, our upper one, being 50. So how are we going to find it? To find the average, we're going to do 1 over the upper one, which is 50, minus the lower one, which was 26, times the integral from 26 to 50 of this function, which was 0.0004 t squared plus 0.053 t plus 2.40. All of that with respect to t. Okay, that looks pretty nasty, but let's go ahead and do it. We can do this together. You're definitely going to want a calculator on this one. You're going to get some nasty decimals. We're just going to approximate it the best that we can. Okay, so what is 50 minus 26? So this is going to be 1 over 24. And let's start some integration here. So what's the integral of 0.0004 t squared? Well, that would be 0.0004 times t cubed over 3 plus the integral of 0.053t would be 0.053 times t squared over 2 plus, and then the last one I'm just going to write it as 2.4 t is what you have, because you have anytime you integrate it, you just constant, you just add the variable. And this is once again from the numbers 26 to 50. Okay, so what does that mean I need to do? It means I need to take all this junk, I need to plug in the number 50, I need to plug in the number 26, and I need to subtract them. So this is going to be 1 over 24 times. I know this is ridiculous, but let's write it out. 0.0004 all divided by 3, and this would be 50 cubed, plus 0.053 divided by 2 times 50 squared, plus 2.4 times 50. All right, that's our first number. Then we need to take that number and subtract from it, plugging in 26 into the exact same thing. So this would be, and make sure you use parentheses, 0.0004 all divided by 3 times 26 cubed plus 0.053 divided by 2, that's times 26 squared, plus 2.4 times 26. Okay. I'm not going to lie on this one. I would have used that table feature on my calculator, making my function that nasty function, and then I would have just evaluated it at 50. I would have evaluated it at 26, and I would have subtracted those two numbers. Rather than typing that all into my calculator twice, again, I would have just used that table feature in my calculator, evaluating it at 50 and evaluating it at 26 to get those numbers. You're going to need to do a decimal approximation anyways. When I do my decimal approximation, if I round this to 2 decimals, I'm getting approximately 5.01. It doesn't tell me what to do, but it says find the average population of the world. Let's take a look at this. This is P in terms of billions if we reread it. P in terms of billions of people. So when I get 5.01, that's an average. So what was the average population from 1950 or 1976 through 2000? The average population was approximately, I don't know, approximately 5 billion people is what we could say here. So there was about 5 billion in the world. To give you an idea, now estimates are over 7, almost 8 billion people in the world at this point in time. They are doing a census this year, though, so we'll see if that number even increases higher than that. Okay, I do want you to know that here it says find the average population. Average in this sense is not really a good problem to me. Because what was the average population over this 24-year span that we're looking at? Well, in 1976, the population was much lower than the population in 2000. So an average population here doesn't really mean anything. It doesn't mean each year the population was approximately 5 billion. It means if we added up the population of all of those years and divided it by the number of years, I get 5 billion. But the real population growth here is exponential. It looks, well, according to them, it's quadratic when we're talking about billions. But population growth, again, in 1976, the population is nothing like the population in 2000. So I don't like the application of an average value here, but this is what was in this book, so this is what we're going to do. There are much, much better problems where the average value of something is much more applicable, much more important.